Very similar example in example 3b, another situation where we're looking at this earthquake formula. 1995, an earthquake in Mexico registered 8.0 on the Richter scale. In 2001, an earthquake of magnitude 6.8 shook Washington state. How many times more intense was the 1995 earthquake than the 2001 earthquake? So again, I want to use this formula that we used before, the log base 10 of I1 over I2 equals M1 minus M2. Okay, and again, my original formula from the word problem in example 3a didn't have the base written in, but it's a common log because the base isn't written. The base really is 10. All right, so if we look at our earthquakes, 1995, our earthquake was stronger. It was 8.0 magnitude. Our 2001 earthquake, the magnitude was only 6.8. So I want my larger magnitude to be M1 here. 8.0 minus 6.8 equals the log base 10 of I1 over I2. Now we can subtract. 8.0 minus 6.8 is 1.2. And now to figure out what I1 over I2 is, what we get when we divide those intensities, let's write this in exponential form. So I'll come over here now. This means 10 to the 1.2 power equals I1 over I2. On our calculator, let's take 10 to the 1.2 power. And that's 15.85 times the intensity. Okay, so again, there's a really big difference in how strong these earthquakes are, even though we only see it as a 1.2 difference based on the magnitude and the Richter scale. That Mexico earthquake was really almost 16 times as strong. All right, so this all comes from the fact that seismographs measure such big numbers. Logarithms help kind of scale it down a little bit and give us something that is a little easier to compare.